Hello and welcome to the Tech Hearth. I'm Ryan, and today we're going to be doing an introduction to Meshtastic. So what is Meshtastic? Meshtastic is a low-powered, long-range, off-grid mesh network that can be used to send text messages and communications back and forth. So let's break that down a little bit. What do I mean by long range? Well, the current longest range record as of right now when I film this is about 330 kilometers. And that was between a couple of mountains. So that's definitely more than you're going to see on a normal day-to-day usage of this thing. More typically, from what I've seen, when I've been listening, it's been 25 to 30 miles, which is pretty good in terms of direct communications between nodes. That's more than enough for what I have planned, and it's pretty impressive, honestly, for something that uses 915 megahertz and such low power. And so let's talk about the low power aspect. These are using milliwatts of power to send messages, text messages back and forth. The boards themselves, the radios themselves, are very tiny and can run for days or weeks off of very small batteries. Compared to like something like this, which was an amateur radio, like a little handy talkie, where the battery in this thing is very large, or like this, which is a GMRS radio, and the battery for this, it's the entire back of this is essentially the battery, and this will run voice communications for a couple of miles without the use of a repeater for a few hours. And so instead, if we can use a battery that is, say, the size of this to power an entire board, an entire radio for days, it's a lot more efficient. So off-grid. Meshtastic is a fully off-grid network. There are ways to tie it into the internet and use the internet to extend your range, but at its heart, at its core, Meshtastic is an off-grid mesh. And that means that all of these nodes can talk to each other and pass messages back and forth without the use of the internet. These specifically, you'll notice this one doesn't have a screen at all. This one does have a screen, but neither of them have a way to add messages into the grid on their own. These pair via Bluetooth with an app available for iOS and Android. Since they use an app, there's some argument that these aren't fully off-grid because you still need to have a device which can either interface with them over USB or connect to them via the app through Bluetooth. And for that, we've got something like the T-Deck here, which has a keyboard and a screen, and this can be used fully off-grid, just send and receive messages directly off of this as if it were a BlackBerry or something like that. So why do we want to use Meshtastic? And why do we want to use a mesh? So as I record this, just in the last couple of weeks, we've had two major hurricanes hit Florida, Georgia, South Carolina, North Carolina, and Tennessee. These were hurricanes Helene first, and then Hurricane Milton came through second to hit just next to Tampa. And these hurricanes were both pretty destructive. Hurricane Helene more so, but they take down communications and network and power in an area for a long time when a hurricane comes through. Where I live in the Midwest, we don't need to worry as much about hurricanes. We're pretty far inland. We'll get some storms if there's a big enough hurricane, but it doesn't generally cause a huge issue for us. But we do get other large storms, such as huge windstorms. We get tornadoes. There is flooding that comes around every now and then as a result of the rivers rising. And we get the potential for earthquakes here. And with all of these natural disasters, there's the potential for telecommunications or power outages for an extended period of time. And for that reason, it is good to have a backup. I have been a licensed amateur radio operator for a very long time, so I have access to amateur radio and to repeaters and to frequencies that let me talk to people and relay messages quite far away outside the affected zone. However, many of my friends and family are not licensed, so I have no way to talk to them in the event of a natural disaster. I won't know what's going on with them. I won't know if they're safe. I don't know if they need help. And so that's where something like Meshtastic, which uses unlicensed frequency, so you don't need to have a license to use this, and it's a lot more accessible in that you don't have to pass a test, you don't have to go through and get a license in order to essentially just send text messages back and forth. So my plan right now is to build a mesh network that covers my friends and my family so that in the event of a natural disaster, I can still talk with them. And it doesn't need to be a natural disaster. We recently had a solar eclipse at the start of this year, and enough people came through my area, and I was traveling south to go view the eclipse as well, so this was my experience during it. All the cell networks got completely overloaded. You couldn't get map updates. You couldn't send or receive text messages. I couldn't talk to my family. I couldn't figure out where we were going to be. Very, very difficult situation. Something like Meshtastic gives you an alternative. It doesn't replace the cell phone network, but if in places where the cell network is down or unreliable, it can give you additional options. For that reason, it's very good if you're going to be going out camping with a group of friends or hiking. You can each of your friends can take a Meshtastic device with them and send and receive messages back and forth. As long as you've kind of got line of sight to at least one or two others, then you'll be able to pass messages along just fine. It's really good if you've got natural topography that might be in the way and prevent you from using something like GMRS to communicate. You can instead take Meshtastic nodes, and then it'll be able to kind of go around obstacles. It's like if you have a mountain, then radio signals don't really go through the mountain. They have to go over it or they have to go around it. And that's something where most radio signals at the frequencies that most people can do just are not very good at. And at the frequencies they are good at, you have to carry a lot of equipment for you. You have to carry a lot of equipment with you. Where I live, I'm fortunate enough to live fairly close to my parents. So in the event of a natural disaster, I have options. I can walk to their house. It would take me a couple of hours, but I could theoretically walk to their house. But if I don't have to walk to their house, I don't really want to walk to their house. We tried using GMRS radios to talk back and forth, but there is enough of a hill in between us. Actually, there's a couple of large hills between us, even though it's only a few miles, that the GMRS radios are very unreliable. Now, we could get bursts of static here and there, but that doesn't make for a reliable method of saying, hey, I need help. And that was with us, actively trying, knowing the other person was there and transmitting, and that let us know that there technically was a signal being received. It just contained no useful information. With something like Meshtastic, I can set up a little node at my parents' house, at my house, at friends' houses, and they can connect into the broader mesh and relay messages around those obstacles. I'm lucky enough where I am that I've got friends that are technically, clearer shots, even though they're further away than my parents are. There are clear enough shots to their houses and to where they work that we can bend a signal effectively around the mountain, or around the hills, so that I can still talk to my parents if I needed to. So for me, Meshtastic is a backup. It's a way for me to be able to talk to the people that I care about in an emergency and make sure that they are okay. So as part of that, like I said, I'm going to be setting up a mesh network across my area. This will help me, this will help others in the area who also want to be able to send and receive messages. And this video series that I'm starting here will kind of detail the whole thing. We're going to be starting off with setting up these devices. We're going to be configuring them, building them out in cases and batteries, and getting them fully spec'd out and functional. I'm going to walk you through how to plan out a node deployment using some various, there's some pieces of software out there that make the planning process a lot easier. And I'm going to walk you through how to actually set them up. So the three devices that I have are, from what I understand, kind of some of the more popular ones in the Meshtastic community. We've got the Lilygo T-Beam. This one has a screen on it so you can view messages when they come in. It's got a fairly large battery on it, and it has a GPS antenna that comes with it, so that this is perfect for a deployment in like a car or something like that, where it's going to mostly have consistent power, or if you're out hiking, it's got enough power there and an ability to send and receive location information. That said, this particular model is built on ESP32, which uses a lot of power, so this is less useful for a permanent solar node, and I'm going to need a few of those. So for those permanent solar nodes, what I have here is the RAK Wisblock. This is not built off of ESP32, and this uses very, very, very little power. I can run this off of the same size battery for a week. So putting this on a solar-powered node with a little battery and a solar panel in a weatherproof housing somewhere up high, this thing will send and receive messages and relay. And so these boards are going to end up being kind of the linchpin of my mesh network. And then for on the go, we've got the Liligo T-Deck. So the T-Deck looks quite an awful lot like a BlackBerry. It's got a keyboard, a little trackball, and a screen. And then on the back, we have the ability to add a battery. It has a speaker, so you can send alerts. And it has a Grove connector for GPS. This whole thing I'm going to be building out into a case, and I'll be showing off that process with an antenna, which will come out of the top like this. So it'll be a little bit more sizable than a standard BlackBerry, but it will also be able to function completely off-grid and not be reliant on the cell network. That's what's going to be coming up. Next time, if you decide that you'd like to follow along with me, next time I'm going to be working on my Lilygo T-Beam cases and build out, and I'll show off that full process. It's not too hard, but we're going to step through the full configuration process from step 0, where you just received yours, coming straight out of the packaging, all the way to being able to send and receive messages on the mesh. So I really hope that you join me again next time for that. And thank you again for joining me here at the Tech Hearth.